so we're on to the guided part of today's lesson. So this is linked to the anchor task, just in that we've got the same two items over here. So, a couple of questions. If we poured these liquids into the jug separately, where would the liquid come up to on the scale? And then secondly to that, what does each small interval on the scale represent? So we'll start with the litre bottle of water over here. So we've got a litre of water in this bottle. Where will it come to if we pour it into the jug? I'm very much hoping that this is straightforward, people. It says 1 litre here. So if we pour 1 litre of water into our jug, it's going to come up to the line that says 1 litre, or at least it should do. 1 litre, just to confirm, is 1,000, or 100, 1,000 millilitres. So hopefully you can see on our bigger scale here, we're going up in hundreds, and we're going up in hundreds of millilitres. So that is an M, I promise you. Millilitres. I forgot how annoying it was to write with a mouse. So 0, 100, 200, 300, that's 300 millilitres. This is 500 millilitres, or half a litre. And then we get up to 1,000 millilitres, which is where our bottle of water is coming into. And then we've got the Sprite, the can. So they are a standard 330 millilitres. So on the scale then, we've got, what does each small interval on the scale represent? So we've got lines halfway between our larger intervals that are marked on as hundreds. So halfway between 0 and 100, hopefully you're shouting, is 50. And again, that's 50. Oh, this is so annoying with the mouse. 50 millilitres, okay? So let's just have an example up here. This one would be 800. I think I need more practice at this. And 50 millilitres. I might have to start typing or something. Anyway, so where will 330 millilitres be? Well, here's our 300. So that's 350. So try and imagine splitting that in half. That's 325. So it would be just above halfway there, approximately. That's approximately, I'm not going to type that out. I'll write that out even, 330 millilitres. Okay, next task, also linked to the anchor task. Which measuring scale would be best to use for each item and why? So we've got 2 different scales here. Now, just a little note on that. Most people would have digital scales. So a bit like a digital clock, it will just have the measurement on the screen for you. And mine can change between grams and kilograms and millilitres and litres, and it will do the old-fashioned pounds and ounces, etc. My mum and my sister still have these things, but I've upgraded myself. Anyway, so you might not have scales like this at home, essentially, is what I'm trying to explain in a very babbly way. So dairy milk weighs 45 grams. So we need to work out if we're going to put it on this scale or this scale. So this one is going round the same as our jug was just now, in hundreds. But this time we're talking grams. We're talking weight, we're talking grams. So it goes from 0 round to a kilogram. This one, we've got 0 here, 500, and that's 500 grams, or half a kilogram. And then this 1 is 1 kilogram, so 1.5, 2 kilograms, or 2,000 grams, and so on. So really for our dairy milk, we're going to be better off on this scale, just because it's that little bit bigger in terms of how we can see the intervals. So on this scale, our dairy milk will probably come just about here, maybe even a little bit closer to the line. But on this one, it'd be really hard to measure accurately that it really was 45 grams, because we've got a lot of a smaller space there. Now, 500 grams of spaghetti, you could technically do on either. We've got a nice clear 500 gram mark here, and we've got a nice clear 500 gram mark here. I'd be tempted to go with this one, just in case you needed to weigh out like 200 grams of it to cook, that kind of thing. So I'd be tempted to use this one again for that. Now, on the flour, we've not really got a choice. you look at this scale, it only goes from 0 round to a kilogram or 1,000 grams. But this is 1.5 or 1.5 kilograms. So we've got no choice but to use this scale. So it would come round to here, 1,500 grams is 1.5 kilograms. Okay, 1,000 grams per kilogram. Right, on to the next one. Now, I've had to add this on here. So I'll just try and explain. It says choose the unit of measure that would be most appropriate to measure the items. And I've had to add on M. So M is for meters, cm is centimeters, kg kilograms, km is kilometers, grams, tons, milliliters, millimeters, and liters. So these ones are going to measure any liquids that you might find. And then I'll just get a different colour pen. These ones are going to measure any length, any distance. And the ones, oh, sorry, that's a distance as well, millimeters. And then the ones that I'll do purple, they are going to measure weight. So you've got kilograms, grams, tons. A ton is 1,000 kilograms. It's not something we hear very often. So a ton is 1,000 kilograms. Right, so I've put down here, discuss with someone at home if you can, if there's anyone there for you to talk to, or send your ideas to us on Class Dojo, or talk to yourself. So pause the video, have a go at working out what you think you'd measure each thing in, and then we'll go through it. Right, so the weight of an elephant. Now, do you know what? I'm wondering if I can try and type instead of writing these out. Let's have a go at trying to type these. Let's go with a nice red one. So the weight of an elephant, you've got two choices really. You could either do tons or kilograms. So I had a quick Google earlier. The largest elephant, average male, is 6,000 kilograms. So that would be 6 tons. So you could use either of those really. 6,000 kilograms, people might have a clearer picture of what that means in case they don't know what a ton is possibly. But either way. Right, can I move this? No, apparently not. It's just going to have to stay there. I'll move it in a moment. The volume of water in a bath. So we've got two options for volume. We've got milliliters or liters. And now we're going to have to go liters. Not quite sure what the average bath would hold. It's going to be a fair few liters. You don't want to measure that in milliliters. Quite a lot of water to fill a bath. The length of an ant. So I'm just trying to picture what an ant would look like. I reckon an ant is probably maybe 4 or 5 millimeters. And I feel like I need to go out and find an ant somewhere. It's probably not quite the weather for it. So we're going to go with millimeters. So millimeters. If I can spell it right. Is it a double L? Yeah, double L. So millimeters. The length of a football pitch. So this is why I added on meters. You wouldn't measure the length of a football pitch in kilometers. It would be completely mad to measure it in centimeters. You've got to go with meters. I think it's about 90 meters. I feel like that's ringing a bell to me somewhere, about 90 meters. You might also hear in football the word yards being used. So yards is an imperial measurement. So in the past, I'm not talking very long ago really, we used to use imperial measurements instead of metric measurements. Oh, there was one on the jug, I think. Yes, look here. So 1 pint and 2 pints are imperial measurements. So it's what we used to use in the past. So you would order milk from your milkman and you'd get like 2 or 4 pints of milk delivered to you in nice glass bottles. Now you'll find in the supermarket the milk is measured in litres, not in pints anymore. So yards, you might have heard of the 6-yard box where the goalkeeper can come out to. So that is literally just the old-fashioned measurement. That's why we say yards in football sometimes. Right, the weight of an apple, that's got to be in grams. I reckon it's about 60 grams, maybe a bit more. I do have an apple in the kitchen. I might try and weigh one later. If you've got one, you could do the same. Certainly not kilograms. So definitely grams for the weight of an apple. Okay, on to the next thing. So it says estimate how much juice the glass holds. Now, just try and think. You get glasses of all different shapes and sizes, I suppose. Try and think of like one of the cups that we've got in the classrooms, you know, the plastic cups that we've got that you drink out of. Try and picture one of those. So estimate how much juice the glass holds. And again, I've put here, can you discuss with someone at home or send us your ideas on Dojo? We'll be doing the same in the classroom. We'll be talking about it. We might not necessarily write anything down for this one. So your choices are 250 milliliters, 2 liters, 0.5 liters, that's half a liter, or 500 milliliters, or half a kilogram. So have a think about that one. And then as well, there's another estimate here. Estimate the height of a door frame. So again, in class, I'd be pointing out the door in the classroom. So, I mean, clearly you've got doors in your house, people. So estimate the height of one of the doors in your house. Is it 20 millimeters? Is it 20 centimeters? Is it 20 meters? 2 kilometers? 2 meters? Or 0.2 kilometers or kilometers? 0.2 kilometers, I will give you, is 200 meters. Okay, so to change between kilometers and meters, we'll do this later in the week. You times by 1,000. So we're literally jumping 1, 2, 3. So 0.2 kilometers is 200 meters. So have an estimate of that. Again, in the classroom, I'd be showing the children a meter stick. You've all seen a meter stick. The yellow ones that we've got in our classroom that are magnetic that stick to the board, that is a meter. So have a think about that as you do that task. Right, make sure you've had an estimate. And now I'll go through it. So on this estimate how much juice the glass holds, for me it's got to be 250 milliliters. If you think about that kind of Sprite that we had, that was 330 milliliters. So your average cup that we've got in school is not going to hold more than that, I wouldn't have thought. We will double check this in the classroom possibly, and do the same yourself if you've got a glass, if you've got a measuring jug, have a go at it. I reckon approximately 250 milliliters. 2 liters is way too big. That wouldn't fit that wouldn't even fit in a big glass that I've got in my house. 0.5 liters, 500 milliliters. I probably do have some glasses that fit that, but not my standard glass that I'm talking about that we've got in the classroom. Half a kilogram, no. Half a kilogram measures weight. We are measuring volume. Okay. So estimate the height of the door frame. So on this one, these things do all work for length, for height, so they could all be a possibility. Now 20 millimeters is 2 centimeters. If you think a door is 2 centimeters, I mean, not even a fairy door is 2 centimeters, people. That's just way too small. 20 centimeters is less than the size of your normal ruler that we've got in class, or slightly more if you've got a 15 centimeter one. Definitely not the height of the door. I'm just going to get rid of these two. Now, 20 meters would be 20 meter sticks. I just know. And no door is that big. I don't even know if my house is that tall, and I've got a 3-story townhouse going on here. I have no idea. I'm pretty sure last year we measured the length of our classroom, so the actual length of it, and it was 7 meters. And you know how big my classroom is. So there's no way a door is 20 meters. Just insane. And if there's no way it's 20 meters, it can't be 2,000 meters, which is what this is. Your door, I mean, the BFG doesn't need a door that big. That's 2,000 meters. No. This is 200 meters. So again, I just know. I can't even, just no. Got to be this one, people. 2 meters, approximately. If you've got anything that you can measure that with at home, go for it, and you can figure out how tall it is exactly. We'll probably do that in school as well. I reckon probably slightly more than 2 meters, just looking at my door in my living room here. But approximately, we're estimating approximately 2 meters. It can't be any of the others. Right, I feel like we might be on to intelligent practice. We are. Right, I shall come back to explain that in a moment.